All right. I am going to take a random paper from this table over here. And we're going to look at the first one. So right here, we're looking at our conditional statements packet. And we've got, give an example of a conditional. I'm going to drop on the end. Just relax. Everybody will get a chance. If it is raining, then it is cloudy outside is your example of a conditional statement. And we have, if it is snowing, it is winter. Okay? Another example of a conditional statement. The inverse that we've got from this is if it is not snowing, then it is not winter. Okay? And our converse, if it is winter, then it is snowing. And our contrapositive, if it is not winter, then it is not snowing. Okay, very nice. I'm going to choose a random one from here. I'm going to turn the page over. It's okay. All right. So for this one, we had to do two statements. One conditional, and then one converse, and see if we can make a biconditional statement out of it. So let's look at it. If you eat a lot of candy, then you must like candy. Okay. If you like candy, then you must eat a lot of candy. Okay. Can we think of a counterexample for it? If you eat a lot of candy, then you must like candy. If you like candy, then you must eat a lot of candy. Right, you don't have to eat a lot necessarily, just because you like it. Okay, so that would be a good counterexample. All right, next we've got if you throw a baseball, you're a baseball player. If you're a baseball player, then you throw a baseball. Can we think of any counterexamples for this?
Yeah, not necessarily, because sometimes baseball players catch.
But they have to at least throw some of the time, don't they? Can anybody name a baseball player that doesn't ever throw the baseball? There's not baseball players that just bat, right? No. Okay, it doesn't exist. Okay. So somebody said a designated hitter. Designated hitter, so that would be a good counterexample. Anybody have a good biconditional, conditional and converse where they have a good biconditional statement from it? You think you do? Let me see. Thank you, Daniel. Okay. So the problem with this one is there could be a good counterexample for it. If there's snow on the ground, it's winter. If it's winter, there's snow on the ground. Sometimes it's winter when there's no snow on the ground, so that would be a counterexample, not a biconditional. All right, I'll go steal somebody else's. I'm going to steal. She tried to hide it. All right. Okay. Okay. So, if it grows on a tree, then it is a fruit. If it is a fruit, then it grows on the tree. What do you think? Can we make this a biconditional statement, or can we think of a counterexample? Nuts grow on trees. Okay. Nobody? Nobody has a good biconditional one? You guys are so good at volunteering. Some of my other classes hate volunteering. Okay. Oh, I like this one. If an angle is a right angle, then it measures 90 degrees. If it measures 90 degrees, then it is a right angle. So if an angle measures 90 degrees, if and only if, it is a right angle. So the only thing is you don't need the if in the front. An angle measures 90 degrees, if and only if, it is a right angle. That's one of my favorite ones because it always works. All right, I am going to steal. Okay. So this last one was a little confusing because you guys didn't necessarily know what a Homo sapien is, right? It's like, good, I like that answer. A Homo sapien is a human. Good. So the inverse, if you are a man, then you are a Homo sapien. So what should be true for an inverse? What do we need for an inverse? What words? Not. So it should be if you are not a man, then you are not a Homo sapien. Which one did she get it mixed up with? Converse, yep. If you're not a man, then you're not a Homo sapien. Is that true or false? False. What could you be instead of a man? A girl. All right. Okay, Olivia. Feel it. It's okay. All right, so here's our shh. Where's my silent llamas? Paying attention. Mouths closed, ears open, eyes up front. Usually, guys, you are way too asleep for me to have to do that. But we're chatty today. Okay, if you are a man, then you are not a Homo sapien. So this is the what? Is this the contrapositive or is this a different one?
This is inverse.
This is inverse. Okay, so to make it contrapositive, you have to say, if you are a Homo sapien, then if you are not a Homo sapien, then you are not a man. Okay, all right. So a counterexample would be, again, being a girl.
Sorry, didn't you just make that one inverse?
That I just did? No, I switched it. See how I took the Homo sapien? I put it in the front. I took the man, put it in the back, and I made them both not. Okay, so we've got this biconditional statement. A point is the midpoint of a segment if and only if the endpoints of the segment. So first we have got to do the conditional. If a point is the midpoint of the segment, then the endpoints are between the segments. That is perfect. Then we're going to switch it for the converse. If the endpoints are between a segment, then a midpoint of the segment, then a point is the midpoint of the segment. Okay? Do we think that's true or false for that converse? False, because if I've got a line, a point is the mid segment of the segment if and only if it's between the two segments. If the endpoints are between a segment, then a point is the midpoint of the segment. Couldn't I have a point right here? It's in between. Is that the midpoint? Is that the middle? No. Okay. All right, 2 more pages. All right. Who am I going to do? All right. So we have right here the biconditional statement. So let's talk about this. What is the hypothesis if two segments are congruent if and only if they have the same measure? What's that first part, the hypothesis? Anybody?
2 segments are congruent.
2 segments are congruent. So this should be if 2 segments are congruent, then they have the same measure. Thank you. Okay, somebody want to tell me what they have for converse? If they have the same measure. There we go. The same measure. Then 2 segments are congruent. Okay. I would say that would be true. They have the same measure, they're congruent. If they're congruent, they have the same measure. Good? All right. If an angle has a measure of 90 degrees, then it's a right angle. So the converse is, if it's a right angle, then it has a measure of, okay. This would be true. So we would say if an angle measure has a measure of 90 degrees, if and only if it is a right angle. So we don't need a counterexample because it is true. So we'd write if No, we'd write an angle has a measure. I hope you're writing this down instead of talking. If and only if it is a right angle. Okay. If and only if it is a right angle. You can do it, guys. Thank you. Alright, I'm stealing Madeline's. Alright. If you are 16, then you're a teenager. So the converse would be, if you're a teenager, then you're 16. Is this true or false? False, because you could be what? 13, 14, 15, 17, 18, or 19. Very nice. You just need one of those, but you can list them all.
19 is the final time you're a child. You're
a teenager.
Yeah.
That is correct, man. All right.